Today. Welcome back. It's Friday the 13th of October. October is Cybersecurity Awareness Month, and it's no coincidence that we're talking about Friday the 13th in a cybersecurity context, and we're talking about that with people who are designing hardware in this course out of digital components. Okay. Let's get here. Does anyone have any comments or thoughts about what we shared in the casino example on Wednesday? It says, explain the significance of the arrangement using and or logic gates in the casino example. So when we say significance, we mean, what does it mean when you're arranging the ands and ors in a certain manner? If you have ands up front, you have more granular control over the probability of a thing to occur with random 1 and 0 entries into multiple inputs. Let me say that again. When you're feeding 1s and 0s randomly into logic gate inputs, and you're using an and, it's more restrictive. So depending on the configuration that you use with ands, parallel versus serial, you're going to have more control over how often a true or a 1 results. When we say a 1, we also mean the light goes on, the current flows. Okay? So when we say 1 or true, we mean the light goes on, the current flows. The circuit is closed. Any questions on that remark so far? We also want you to know that if you work the ands in a series, right, if they're configured in a series, you can decrease the incidence of the true. As opposed to parallel, you increase the true. And the or is permissive, right? So there is an explicit description in your study guide. I encourage you to read that and memorize that. There will be complex scenarios or complex questions in the assessment for Module 3. So what am I saying? I don't want you to be shocked or dismayed. How many of you have been in a plane and you heard, hey, you got to fasten your seatbelts because there's going to be some turbulence, right? Has anyone ever heard that before?
Yep.
Yeah, and they say, hey, put your seat backs and your tray tables, and they're locked in upright position. The captain has lit the fasten seatbelt sign. We're going to have some unexpected turbulence here and there, and we want everybody to be safe. Now, is that cause for everybody to grab a chute and jump out the door? No, not really, right? And everybody's still here to tell about it, right? So things worked out. What I'm doing here is cueing and I want you to anticipate that some things are going to get a little more challenging. In some cases, you're going to look at it and swallow hard and go, that ain't a little challenging. It's a lot more challenging. But one thing I want to encourage you to understand is that if you know and, or, and not, if you know and, or, and not, if you understand what happens when you combine those, and, or, and not, if you take an elephant, as long as you don't try to eat the elephant one whole bite, if you eat the elephant one bite at a time, one human bite size at a time, then you can eat an entire elephant, okay? In particular, I want to call your attention to the student learning objectives that are highlighted on your screen. Student learning objective B says, given a compound Boolean function, derive the equivalent compound logic gate and pseudocode. So we want you to do what we started to do last module. If you're given a diagram, we want you to be able to come up with the Boolean function. We want you to be able to come up with the truth table. And what's the common denominator in every case? The truth table. What do you need in each case, in each scenario? A truth table. If you want to work forwards or backwards from diagram to logic statement to HDL code and back and forth, what do you need in the middle? A truth table. A truth table. A truth table. Every single time. Okay? So just remember, you know the basics. This is like, how many of you have seen Karate Kid? Any of you seen Karate Kid?
Yeah.
This is the wax on, wax off speech right before the tournament, when Daniel-san is like, what do I do? He's got to get ready for the tournament. All he's been doing is what? Paint the fence, sand the floor, wax on, wax off, right? And he doesn't understand. And he starts complaining to Mr. Miyagi. And then all of a sudden, Mr. Miyagi goes, hey, you, wax on, wax off. And then he starts throwing punches and kicks at him, right? And what does Daniel-san do? Wax on, wax off. Starts blocking it. He goes, paint the fence. He starts kicking him and hitting him. Daniel-san is using what? Paint the fence. What I'm trying to get at is, if you know the and, or, and not, and you know truth table, and you know how those work, and you do it, and you practice it, and it becomes reflex, you're going to be okay before I show you the next few things. Now, if you're not there yet, don't freak out with your hands over your head running from the room. Because that's like taking the chute and jumping out of the plane when the captain says, what? Hey, fasten your seatbelts when you're in your seat. There's unexpected turbulence. That's all. Okay? So I just want to tell you that. Because every now and then we get people who go through this next segment and they're like, holy buckets, what did I get myself into? Allow me to articulate or extrapolate or pontificate. In this case, you're going to want to masticate, which is a fancy word that means chew on it for a bit. What I want you to do is to ruminate on this for a little bit, and I want you to notice the due date. By Monday, 10 a.m., I want you to finish assignment 3.1. Now, this is designed to help you, prepare you for the things that are going to hit with your solution. Let me say that again. When the solution comes next, if you're not past this, this is training. This is like wax on, wax off, paint the fence, sand the floor. That's what this is right here. Okay? And I want you to do it. I want you to do it faithfully. I want you to take the time to do it. It's not going to be pleasant, but you have to be ready by 10 a.m. on Monday, because we're going to walk through the solution for this at 10 a.m. on Monday. And if I don't see your submission by 10 a.m. Monday, I'm going to put a 0 down, because you didn't take Miyagi seriously. See, Miyagi had another speech that he gave to Daniel-san. He said, Miyagi teach, Daniel-san learn. You remember this? I mean, seriously, everybody's seen Karate Kid, hopefully. If you haven't, you're missing out. You should look it up on Hulu or one of those, and you should find it and watch it. Okay? Probably out there on YouTube, free. Miyagi said, karate yes or karate no. But karate so-so, very bad. It's like walk on left side, yes. Walk on right side of road, yes. Walk in middle of road, squish, like grape. That's what he tells Daniel-san. He's like, you're either in or you're not. You either do this or you don't. This assignment, you do it. If you trust me at all, if we've learned anything together, if you respect me as an instructor, or you don't respect me, you respect yourself. You don't want to log a 0. You won't be able to submit this late. This is one assignment I will not allow you to submit late. And that's because if you don't do the wax on, wax off, paint the fence, sand the floor, and you don't get through this, when you try to do the next solution, when you add a couple of logic gates and different logic gates, it's going to get complex and you're going to get discouraged. And by that time, this is like the tournament and this is the prep for the tournament. Does everybody understand the analogy here? Do you want to go to the tournament without having been trained? Who among you would rather go to the tournament without being trained? Is there anybody that wants to say, yeah, no, I'm busy, I can't do this? What am I telling you? In the airlines, if you ignore the captain, what happens if you ignore the captain and the precautions of the captain? Can anybody tell you what? Tell me what happens. I know I'm stretching this analogy quite a bit, okay? But I'm building up to this. I want you to trust me. What happens? Do they let you do something that's going to endanger yourself or the other passengers or the crew? They don't. They say, hey, you got to do this, right? So That's one reason why I'm putting out, I'm signaling, I'm queuing. This is one time where you're going to want to adjust your priorities appropriately. Adjust your priorities appropriately. And I'm going to show you part of the solution, but I'm not going to give you the whole solution. What I want everyone to do right now is to download Logic Gate E. Here's what Logic Gate E looks like. Okay? Can everyone see the screen?
Yeah.
Yes.
All right. Now, how many inputs are there?
3.
Just 3. Only 3. And you're going to work from the left side of the diagram to the right side of the diagram, from the inputs to the outputs. So everybody's working from the left side to the right side. Any questions about that here?
No.
No. Are we dealing with any XORs or XNORs or muxes? No, we're not. No, we're not. But can you fill in the blank here? And do you know what kind of logic gate this one is right here?
And
is correct. What about this one here?
or
Are there any other types of logic gates? No. So there are no wild cards. The point I'm trying to make is we don't have a knot in the mix, so we don't have wild cards to make matters worse. Okay? Does everybody understand what I'm saying? Now, let's say you took a diagram like this and you added an XOR. Would you not have what's required for your solution?
Yes.
You'd have at least 4 logic gates. If you substituted this one for an XOR, wouldn't you have what it takes to complete the assignment? The solution, I mean, you'd have 3 different kinds of logic gates. You would have at least 4 of them, right? You get what I'm saying? So again, this is kind of like eating broccoli or doing the paint the fence. Now, let's take it a step further. Notice there are blanks here. I would encourage you to print this, or to be able to scratch in here with a stylus or a marker, or, you know, in paint. You need to be able to, in order for this to work right, here is a suggestion that I want you to heed. There's a blank space here because I want you to consider this to be a different and from this one and from this one. This could be, here's a suggestion, and 1. If you're starting on the left, working toward the right, and you're going from the top and going down, this is and 1. This is and 2, no space, and 1, no space on the label, and 2, no space on the label, and 3, no space on the label. Now, why is this one 3? Because the inputs for this and come after the direct inputs on these 2. These 2 ands engage with the inputs directly. This one does not engage with the inputs directly. Does everybody understand what I mean by that remark? Does anyone have any questions about that remark? So the inputs from this and are derived from this wire and this wire, not from the outside inputs here, okay? Now, the other thing I want to encourage you to know is that when you get to the HDL part of this, you're going to have a chance to log additional credit. Because I'm going to tweak the assignment I just posted, and I'm going to say, if you want to, you can create the HDL, run it, and check your truth table. Okay? Which is really cool. Why is that? Well, you'd have most of your solution built already. All you'd have to do is modify this to some degree, and you'd know what you're looking at. Why else do you want to do this by Monday? Guess what's on your assessment, your first attempt, which has to be completed by 10 a.m. Wednesday, 18 October. Would you care to guess what you also have to turn in and complete by 10 a.m. Wednesday, 18 October next week? Anyone? The first attempt of your module assessment. The first attempt of your module assessment has to be completed. along with your solution. You're going to want to complete your solution, and you're going to want to complete this assignment before you try to do the assessment. Is it going to matter on Monday if you don't have it turned in? You'll get a 0. Should you still do it if you don't have time and you just don't get to it or you forget after you walk out of this class? Should you still do it, knowing that you have to get this in order to succeed in the assessment? It would be a good idea to complete it anyway. And if you turn it in after the fact, you could send me an email. You could provide rationale why your submission was late. And depending on your rationale, if it's valid, I may still accept it. But if you don't have a good rationale, like my dog ate it, or hey, I had business, or something like that, no, that's not going to work. I'm telling you this up front so you know. I'm telling you this up front so that you can. And here's the thing. This is or 1. What would we call this one? And that's just the suggestion here, right? What would we call this one? Or 2. Let's talk about wire labels. Everybody with me? Wire labels. If I'm starting in the top and I'm starting on the left and I'm working my way to the right and I'm working down, what's the label I put here?
W1.
W1 is correct. What's the label I put here?
W2.
W2 is correct. Thank you, sir.
W3.
W3 is this one. Now, what about this one here?
Let's go for W4.
That's W4. So the inputs for this or 2 would be what?
W1 and W4.
W1 and W4. Does everybody get what I'm talking about? All right. In your HDL, remember that this is the big A, big B, and big C. This is outside the entire mess. So if we had a interface view of this logic gate, we would have something that would be in, you could call it an and or, you could call it a 3 and 2 or, you could have a descriptive name so somebody knows what the heck it is when you go inside there. But the point is that you'd have some outline for the larger complex logic gate. It would be a drawing or a diagram of your choosing. It would probably have more of the and character and less of the or character because there's more ands and ors. Are you following what I'm saying? You could trace like a dotted line with or inside there and have a bold or outside there. I'll put a diagram on the whiteboard in just a minute to show you what I'm talking about. You could devise your own symbol for this creation, and all it would show is A, B, and C input, and then it would have out. In this case, the diagram shows Q. Q is out. It's the ultimate out. It's the out at the end of the line, okay? There's a big A, a big C, and a big A, big B, and big C. But here's the thing I want you to remember. When you're doing your HDL, in this simulator, there's a little a here, and there's a little b there. Does everybody know what I'm talking about? Maybe no. Can you see my screen?
Yeah.
Okay. So let's modify this. A, big B, big C are the inputs for my and 3 or 2. And that's what I'm saying right now. You could decide to call this anything you want. Now in here, I'm going to say this first and, okay, this first and is going to be like, this is the big A, and this is the big B. There's a little a here. It's the input for this logic gate. There's a little b here. It's the input for this logic gate. But the combo logic gate, the combined or complex logic gate, has a main input A, capital A, a main input B, and a main input C. Does everybody get what I'm talking about?
Yeah.
The first letter is the big input. The second letter is the one inside the and. And this is the confusing part for this free simulation environment. In this HDL open source environment, they like to use A and B constantly for A and B here, A and B here, A and B here, A and B here, A and B there, A and B there. When they're referring to the HDL, that second letter of reference is always A and B. That's because of the way this was designed with Java by the authors. But you could have another hardware simulation environment, or you could substitute in this hardware environment. But the built-in ands and the built-in ors require the use of a little a and a little b, a little a and a little b, a little a and a little b. The built-in ands and ors that you are using for your complex design, the and, this is actually the built-in and, the built-in or. Could you design an and that allows you to label those two inputs something else like X and Y, or M and N, or C and D? Absolutely you could. But the author is giving you a taste of what a hardware simulation environment is like in industry. This starter HDL is already in there. And I call it gate E. So that's my name for the logic gate. Now, I'm going to close this. And I'm going to close this. And I'm going to tell you right now. This is going to be on the assessment. Oh, before Halloween, you're going to have a midterm exam from Module 1, Module 2, Module 3. This diagram and this solution, it's going to be on the midterm. And that's worth twice as much as any assessment. The midterm is 10 points. Are you ready? This logic gate is going to be in December on what? The final exam. This logic gate solution is going to be on the final exam. And it's going to be on the final exam. And what is the final exam worth? Twice as much as the midterm, which is 4 times as much as your module assessment. It's not open book. You'll have 90 questions to complete in 120 minutes from 6 modules. You won't have time to mess around. Translation. Some big points are going to be on the midterm and the final exam that have to do with this. So if you mess it up going into your first attempt at the assessment, that's okay. We know we can reconcile, yes? We reconcile. By the time you finish, you take your final attempt of the module assessment, I want you to hit it out of the ballpark. Why? Because when you take your midterm and your final, I want you to demonstrate without having to dig up something on your screen because you think you're going to be able to do open book for your exams. You won't. Either midterm or exam is going to have too many questions and the time constraint is going to be too short. Plus, they're randomly sorted and the answers are randomly sorted. If you had a lifeline, it wouldn't help you. If you had somebody on the phone coaching you, if you did a Zoom session, it would be too much overhead for you to work through and you'd be losing precious time on 10 other questions. Okay? Now, why am I telling you this? In any of my classes, you will not see a browser control on my exams. What's the name of the browser control we use elsewhere?
I think it's lockdown.
It's what?
I think it's like lockdown browsers.
It's a lockdown, starts with an R. Anybody know what I'm talking about?
Oh, it's fun.
Respondus. Respondus. I will not use a lockdown browser. And my fellow faculty were asking me, why don't you use a lockdown tool on the web browser, Professor Kentop? You know what I told them? I said, it's unfair to students who are going to do lookups with their cell phone while they're taking the web screen that's locked down. Meaning if you have more tech and more screens, you're at an advantage in the context of a Respondus lockdown browser. But if all you have is one screen to work with, well, you don't have as many resources, so it's harder for you to do that. I don't like using Respondus Lockdown. It tends to muck with the web browser when all you're trying to do is take the darn test. That's strike one. Strike two is there are workarounds that are too easy. And strike three, students with less tech resources are at a disadvantage in an environment where Respondus Lockdown is. So why am I sharing this with you today on Friday the 13th? And October is cybersecurity month. I'm telling you this in advance so you can hack the exam, so to speak. I want you to know, no punches pulled. This is the expectation that you're going to face. Between now and Halloween, we will complete a midterm. You'll have to do it on your own. It'll take 1 hour. You'll have about 60 minutes to finish 45 questions. That won't be a lot of time. You're going to want to brush up and review for your final attempts in Module 2 and Module 3. I will be putting the final attempts of the Module 2 and Module 3 assessments out over the weekend, and I want you to finish those. By the middle of next week, I do want to have all your stuff scored. I keep saying that I'm going to do that, and I keep having to deal with backlogs and other submissions, and there have been special meetings with folks, unexpected special meetings with folks, and for good reason, right? People are graduating, they're getting jobs, they're getting internships. So I keep having to get like sidelined to take care of other business. But I'm not making this up, okay? Now, you're gonna have a chance to brush up and clean up and resubmit on all the assignments and the solutions as needed by the time you take your midterm. I want you to be fully practiced and fully ready. And then you'll be in good shape for the final. Because as soon as we clear the midterm, we're going to get into the fun stuff. We're going to be dealing with hands-on hardware. And we're getting away from the design aspect. So the first half of this course is really about design of logic gates and complex logic gates. And what you're doing right now is like, this is the last phase. You're almost at the finish line. It's going to be tiring, but it's good because you're going to feel great when you take this diagram and you get it right. And then you'll know how to answer the freaking question on the assessment, and you'll get that right too. So why is it I'm saying you have to have it and you can't get an extension? Because it's that important, okay? With that in mind, I'm going to review the criteria that you must complete for your solution. And then we're going to use the rest of the time in class for one-on-one assistance or for review, okay? But truth be told, you get better at this stuff. Where are we? You get better at this stuff when you practice more. And you have to do that. You have to practice. So there you have it. Are there any comments, questions, concerns at this point? Is everyone's HDL working as expected? Does everyone have access to HDL simulator? I found out last season somebody didn't have access to it because their laptop died and they didn't have it. Are we good?
Yep.
Okay. I'm going to go back to this. So I provide starter HDL. You just saw the starter HDL. When you open this file, I'm doing some of the hard work for you. Wait a minute. Starter HDL. So I am providing you, I didn't save this. I'm providing you the starter HDL. And I want you to notice that I have a single W1 here. In the starter HDL, I have X. I've used X in place of what should go there, right? Does everybody understand that some of the outs here are not out equals out? So when you're working with the diagram, I expect you to see how many more W's in the mix. 4 more. W1, W2, W3, W4. Does anyone need an explanation again of what I'm talking about by that? Not really, right? Now, your diagram may have and 1, your diagram may have or 2, but in the HDL, here's a tip. You don't want to use and 1. You don't want to use or two. Your diagram can have that, so you keep it straight in your truth table. You label these things for your truth table. And your truth table is going to have intermediate results. So you're going to have an extra column for this and one result. You're going to have to insert extra columns each step of the way on your 8-row truth table, but your 8-row truth table will remain 8 rows. You need a 3-input template to do this exercise. You should know where to get the 3-input template at this point. And if you don't have copies of 2-input, 3-input, 4-input, 5-input, 6-input, you're going to want to have those handy on your own laptop from now on. Okay? Does everybody understand what I'm saying? You won't have time to dig it up, go back to the module, find those templates, download those templates, do it all up front, get it all out of the way. Okay? Once again, you would label this so that you can do the truth table accurately. When you get to the HDL, you will not use and 1, and 2, and 3, or 1, or 2. You're not going to use X. You're going to substitute other A's and B's, okay? Or W1s. We have 4 of those, W1, W2, W3, W4, right here, okay? Now, let's make quick work of the solution. You're going to design a complex logic gate using 4 or more logic gates. Now, if you did this already, where you drew a diagram, and 3 of them were different, and at least one of those must be an XOR, XNOR, or MUX, and you have to have at least 4 of them, using 4 or more logic gates, then what do you have already? What am I saying? If you did this already, what do you already have in the bag? This. Okay? Everybody with me? It's a twofer. You get double credit for that. The truth table, you know you're using a 3-input truth table. You know you're going to be labeling the diagram, right? The canonical expressions. Again, we're going to be going over this solution on Monday. So we need you to do this for yourself, because if you watch the professor doing wax on, wax off, paint the fence, sand the floor, but you can't wax on, wax off, paint the fence, sand the floor, then the rest of the early next week is, but the closer we get to Halloween, the scarier it's going to get. And I do not want that for you. Okay. The HDL file with a logic statement. Have I not already given you a starter template? Yes, I have. True and false case that matches input options shown in the truth table. Now, what do I mean by that? When you do the HDL and you run this in your simulator, you're going to use a true case and a false case. You're going to capture a screenshot of each. Does everybody know what I'm talking about? So you'll know which inputs A, B, and C will result in a true. You'll know which inputs result in a false. And you're going to give me a screenshot of each of those cases in the HDL simulator. I am not talking about your truth table. I'm talking about the simulator. I want you to take this into the simulator. All right. You're going to have a single Word document and a separate HDL file. I want to see your finished HDL file. Okay? All right. So, is there anything else we need to cover in our study guide before we finish? I want to go back to this. Is it okay if I take just a moment to go back to this?
Yep.
The thing I want you to remember is that there is a signal input. Input A is a signal. It's like a switch, right? So what happens is you feed a 1 or a 0 into here, and then based on the based on the value, it's gonna use this input or this input. So what you feed into here determines if I'm using this one or this one for the input that ends up over here. That's what's really going on here. The A input values tell the logic gate which I sub 0 or I sub 1 input to utilize to feed in with the truth table. But the thing that I want to stress again is, if you look at the truth table still works like every other logic gate. We have 3 inputs, therefore we have 8 rows. We have zeros and ones, 0, 0, 1, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 0, right? And the thing is that we have these, what are these? NANDs. Which means when you're rendering the output of the truth table, you got to understand off the top of your head, what does a NAND do that's different from an AND? Okay? What does a NAND do that's different from an AND? And we talked about NANDs before, okay? They look similar to an OR, but it's not an OR. Because the thing that triggers a single false is different than the single false that appears for an OR. That's something I want you to keep in mind with this diagram in particular, especially when you're doing the final attempt of your module assessment. Any questions on this before we clear? Okay. I'm going to be available in my office from 11 to 1 today, and then after 2 p.m. I'm also going to be available on Saturday from 8 a.m. to 1 p.m. I'm also going to be available on Monday, same hours, right? Just remember, we've got to have your submission for 3.1 by the time we get to class Monday. I hope you have a great weekend. And I'll start looking at the diagrams you've submitted for your 3.0 submission, and we'll refine from there. Does anyone have any observations, comments, questions before we go? Has anyone been to the casino since our Wednesday class?
No.
No one's been to the casino since then?
Casino on weekday is crazy.
Are you going to look at a one-armed bandit? Are you going to look at a slot machine the same way for the rest of your life?
Never. I don't even like them in video games. They suck. It's always rigged.
Yeah.
What?
Yeah. Hey, what we're talking about with slot machines applies to video games. Yeah. You hit the nail on the head. That's an ideal comment. Thank you for sharing that. So in other contexts where it's entertainment and you're not dealing with, like, I don't know, serious financial losses and bankruptcy, right? For those of you that enjoy video games, you could use the same concepts here to, like, dial up or dial down the difficulty levels, depending on what's going on, right? Really cool stuff. Because, you know, modding, does anyone mod games? You heard of the term modding games?
Yeah.
Okay. All right, cool. All right, have a great weekend.
Wait, Professor, can I speak to you after class?
Yes, you can. I'll go ahead and stop sharing and stop recording and sit tight in the session.